doing this, right? Do we want to just like keep trying random groupings of cake and sugar cones? I guess we could go about it more systematically, right? Like 2 and 1, 2 and 2, 2 and 3, 2 and 4, etc. But still, that's going to take a long time to negate all of the possible ones, right? So instead, what I'd rather do is look at this in a graph, right? I'd like to be able to take this information and look at it in a graph. In order to do that, I got to know what the graph is supposed to look like. I got to have some things to graph, right? So to graph these ideas, I need to assign some variables, right? So perhaps I say that X is the number of batches of cake cones produced, and Y is the number of batches of sugar cones produced, right? That works. That's no problem. We could have called them A and B. We could have called them Y and X instead of X and Y. So it doesn't really matter. It's very arbitrary. Because remember, at this stage of the game, all we're doing is taking a real context and representing it mathematically so that we can go and solve and then take it back into context. So this is the part where we're just representing this mathematically. So that gives us this system of inequalities, right? I know that 1x and 2y is going to have to be less than or equal to 12, right, due to the mixing constraint, and that 2x plus y is going to be less than or equal to 12 due to the baking constraint, right? No problem. So I've got those two inequalities, and I'm going to put those in Desmos. Now I'm going to try to switch over to Desmos right now. It may knock me off, so I may have to do some video fiddling. We'll see what happens, right? We'll see if it's still talking to me. Go to Desmos. You're probably not seeing this. You may not even be hearing this. I'm going to keep up a little pattern just in case you are. Less than or equal to 12. 2x plus y less than or equal to 12. There it is, right? I also know that x has to be greater than or equal to 0, and so does y, because it doesn't make any sense for us to have a negative number of batches, right? So these points here are going to surround what seems like a feasible region, and of course I just deleted them, which was dumb. Let's try that again. Use my snipping tool to bring this over. And I am still recording, so you may have heard all that, you may not have. That may have just been dead air. If it was, I'll listen to it and give you different directions. But I'm going to kill off the manual graph I put in here and just copy and paste this Desmos graph. Let's just see what happens. So the Desmos graph gives us a pretty clear indication of what's going on. Now, in Desmos, sometimes it's hard because Desmos just chooses the colors for you to know what it is we want to really use here. So I'm going to make myself a little color region on top of it. I probably should have told you how I did that. I went to Insert, and then I went to Shapes, and I used the Freeform tool. Now I have this blue, this pretty blue box. The blue, that's a quadrilateral. Blue quadrilateral represents the feasible region. And that's a phrase that you're going to hear a lot. The region that contains all the possible combinations of sugar, well, we'll say cake since it's X, cake and sugar cones that meet all the requirements, right? All the constraints. So there it is. Let's see if we can highlight this blue. That's not what I meant to do. No, that's close enough, right? We'll use that blue. That's fine. So there we go. So that's the feasible region. So what that means is all of these points in here that are in this blue quadrilateral, those are the ones that are possible. So now we've contained it, right? We know that if I try to make 7 batches of one and 2 batches of the other, right, that's going to fall out here outside that feasible region. So that's not going to work. But if I tried to do like 2 of one and 5 of the other, right, that's going to fall in here and that would work just fine. So now we know what it is. Now, a lot of times we get constraints that constrain us even more. So for example, if I know that in the past I've had a steady demand for 4 batches of sugar cones and 2 batches of cake cones, I can use that information to my advantage, right? So for example, at least 4 batches of sugar cones, well, that implies that Y, which was our sugar cones, has to be greater than or equal to 4, right? So that's different than what we had before. It also means that at least 2 batches of cake cones, all right, well, that's going to imply that, yeah, that'll work, that our cake cones, right, X, has to be greater than or equal to 2, right? So that's going to work out really well for us. And it changes our graph just a little bit. So I'm going to go back over here and I'm going to change my graph 4, 2, and it's going to change the feasible region to this very small piece. So instead of the region above, I'm going to end up with this little bitty region here. I'm going to shrink this down so that I don't end up with quite so much work here. Okay, in fact, let's crop this. It's a fun tool. We use the cropping tool. We can come in a little bit. There we go. That's nice. And so that means, again, insert, shapes, freeform. You just click and release. Click and release. Click and release. Click and release. And then once you come back around to your first point, it's going to give you that quadrilateral. So there's our new feasible region. And what's interesting about this is that it has just reduced the number of points I want to try pretty dramatically. So I'm going to say I want to do this. Put it over here with its little yellow box on top of it. Let's bring that back to the front. Or not. There we go. Okay. And so this new feasible region has just 4 feasible points. And so that's going to be 2, 4, and 4, 4, and 2, 5, which we can see as the corners, right? But also we have 3, 4. Now the point 3, 4 is inside this region. It's along the border on the bottom in between 2, 4 and 4, 4. The reason I know it'll work is because it's whole numbers, right? So you wouldn't want partial batches, right? Like a 3 1/2, but 4 1/4, that kind of thing. That doesn't work. The way that people manufacture things is they establish what's the most efficient batch size, and that's what they use. And at that point, it becomes just as economical to make a batch of that's a full size than it is to make one that's partial. So you wouldn't make a partial one anyway. So that kind of brings us down to the feasible